Today we're going to be going over transformations. You're going to be following along and writing this down. The 2 pages that you picked up are also going to be glued in your journals for future reference. So today we're going to be going back over what congruent means. To be congruent means to be the same shape, and the same size. So if I have 2 shapes that are congruent, they're going to be exactly the same shape, both triangles, and both the same size. When I say 2 shapes are similar, that means that they have the same shape, but they have a different size. An example would be a small triangle and then a bigger triangle. When I have 2 shapes where one is smaller and the other one is bigger, that's called similar. Scale factor. A dilation means that you are taking a new shape and dividing it by the old shape. You would pick a side that they have in common and take the new side and divide it by the old. If your scale factor is greater than 1, that means that it's an enlargement. An enlargement means that you have a shape that started off small and became bigger. If the scale factor is less than 1, that means that it was a reduction. A reduction means that the shape that you have got smaller. When you multiply by a scale factor that's equal to 1, that means that it stays exactly the same. It didn't get bigger or smaller. So if I had a rectangle and I multiplied by a scale factor of 1, it stays exactly the same. Translation. A translation means to slide a figure. When I slide a figure, I am moving it either left or right, or up or down. To write a shape algebraically for a translation, you would take the x value and add or subtract your number, and then you would take the y value and add or subtract. Remember that the first value is telling you how far your graph is moving from left to right. If they are subtracting, your graph moved to the left. If they are adding, your graph moved to the right. The y value is telling you how far your graph is moving up or down. So this value here is moving your graph up and down. If they're adding on the y value, they move the graph up. If they're subtracting, they move the graph down. So again, the y value is telling you which direction the graph is going up or down. Reflection. Reflection means you're flipping your shape across either the x or the y axis. When you reflect your graph across the y axis, it will always have the same algebraic expression. If you flip it across the y, that means the y stays the same. To write that algebraically, you would write x comma y, and you would leave the y alone. The y stays exactly the same, and the x becomes a negative. When you're reflecting a graph across the x-axis, that means that you're flipping it over the x. The x is going to stay the same. To write that algebraically, you would write x comma y, and then you would leave the x alone on this one, and the y becomes a negative. Rotation. A rotation means to turn your shape. When we rotate a shape, we typically rotate counterclockwise. Let's go back over our rules. This is quadrant 1. Over here we have quadrant 2. Down here we have quadrant 3. And at the very end we have quadrant 4. When I rotate my shape, we always start at 0 degrees, then 90, 180, and 270. Since we're writing our degrees, let's go ahead and write that these were rotated counterclockwise, which means to the left. So if I rotate 90 degrees counterclockwise, this would be my rule. 180 counterclockwise, 270 counterclockwise. Right now, we're rotating all of these to the left. So to write our rule, we always start with x and then y. Then we go y and then x, x, y, and then y, x. Let's go ahead and write our signs now. To get to this quadrant, I have to go to the right and up. So that's positive, positive. To get to this quadrant, I have to go to the left and up. That's negative, positive. To get to this quadrant, I have to go to the left and down, which means negative, negative. To get to this quadrant, I have to go to the right and down. That's positive, negative. Now these are my rules. Anytime I say I made a 90-degree counterclockwise turn, this is my algebraic expression. If I say 180, this is my algebraic expression. 0 degrees, x comma y, and 270 counterclockwise, this would be my algebraic expression. The only time it changes my rule is when I go the opposite direction. So let's say on our assignment, it said 90 degrees clockwise. Since all of these rules are counterclockwise, if your paper said to rotate clockwise, that means you go this direction to the right. So a 270 counterclockwise is the same as 90 degrees clockwise. So these two have the same answer. And this one over here in quadrant 2 is the same as 270 clockwise. 0 and 180 will not change for counterclockwise or clockwise. Lastly, let's go ahead and write how many turns we will be making. For a 0-degree rotation, that is 0 turns. For a 90-degree rotation, you are rotating 1 time. For 180, you will be rotating 2 times. And for 270, that means 3 turns. You will now work through the task cards with your partner. Make sure that you're working on the assignment and you're going to be turning in what you've done in class before you leave for the day.